In today's video, we are going to explore the arrangement of electrons in atoms and understand why most atoms, such as fluorine, have an incomplete outer shell of electrons. This idea is absolutely essential in chemistry because for an atom to be stable, it must have a completely full outer shell of electrons. If an atom does not have a full outer shell, then it will need to react with other atoms in order to either gain or lose electrons until it achieves stability. Let us begin by looking at how the electrons are arranged in a sodium atom. The atomic number of sodium is 11, which tells us that it contains 11 protons and also 11 electrons. These electrons are not placed randomly, but are organized into shells that surround the nucleus. We draw these shells as concentric rings, and the electrons are filled from the inside outward, starting with the shell closest to the nucleus, because that shell has the lowest energy. The first electron shell can hold a maximum of 2 electrons, the second shell can hold up to 8 electrons, and the third shell can also hold up to 8 electrons. When placing electrons in these shells, the best way to draw them is to place the first electron at the top, then the next at the right, then bottom, then left, and only after this do you go around again to place additional electrons in each of these positions. It may seem like an odd method, but it helps to visualize the distribution. Once the first shell is full with 2 electrons, we move to the second shell, which gets 8, and then the final leftover electron goes into the third shell. Since this outer shell only contains 1 electron instead of the maximum 8, it needs to be stable. We say that sodium is unstable. This simply means that the atom is likely to undergo a chemical reaction with another atom to either lose or gain electrons in order to get a full outer shell. Most atoms are in this same situation when they are not bonded to other atoms. They have incomplete outer shells and therefore react with other atoms to form molecules or compounds in an effort to become stable. However, there are some special atoms, known as the noble gases, which are located in group 0 of the periodic table. These elements, including neon, have completely full outer shells, and because of this, they are already stable. This stability means they do not need to gain or lose electrons, and therefore do not easily react with other substances. In exams, you may be asked to determine the electron arrangement of any of the first 20 elements on the periodic table. For instance, if asked about the electron structure of argon, you would first find that its atomic number is 18, which means it has 18 protons and also 18 electrons. Starting from the nucleus, you would place 2 electrons in the first shell, 8 electrons in the second shell, and the remaining 8 in the third shell. This adds up to 18 and creates a full outer shell, making argon a very stable element. We can also write this electron arrangement numerically as 2, 8, 8, representing how many electrons are in each shell from the inside out. When drawing these structures, you may be asked to use either crosses or dots to show electrons, both of which are acceptable. Let us now look at another element, calcium. Calcium has an atomic number of 20, which means it contains 20 electrons. Arranging them from the nucleus outward, we place 2 electrons in the first shell, 8 in the second, 8 in the third, and the remaining 2 in the fourth shell. We would write this as 2, 8, 8, 2. Since the fourth shell only contains 2 out of a possible 8 electrons, it is not full, meaning the calcium atom is unstable. However, if calcium were to lose its 2 outermost electrons, the third shell would become the outermost shell, and it would be full, thereby making the atom stable. Despite losing 2 electrons, calcium still contains 20 protons, so it now has only 18 electrons, giving it an overall charge of positive 2. We now call it a calcium ion rather than a calcium atom. When representing ions, we draw large square brackets around the diagram and show the overall charge as a superscript in the upper right-hand corner. The electron configuration of the calcium ion would now be written as 2, 8, 8. Finally, let us take a look at fluorine. Fluorine has an atomic number of 9, meaning it has 9 protons and 9 electrons. The first shell gets 2 electrons and the second gets 7, giving a configuration of 2, 7. This is the opposite of calcium's situation because fluorine is just 1 electron short of a full outer shell. To become stable, fluorine would need to gain 1 electron from another atom. When it gains 1 electron, it becomes negatively charged and is referred to as a fluoride ion with a charge of -1. Its final electron configuration would then be written as 2, 8.